Hello everyone and Assalamualaikum. So we are group 5 from class 5XBME2, consists of 3 members which are Muhammad Najmuddin, Muhammad Naim and Muhammad Syariah Hakim. In this video, we will present about one of the steady flow engineering device, which is the throttling valve. So we hope that you will enjoy this short video. Basically, for the first part, we will explain about the throttle valve itself, on the concept of design, shape, mechanism and physical features. A throttling valve. First, a throttling valve can open, close and regulate fluid flow. Next, throttling valve are a regulator valve. And then, a throttling valve have a disc that do not only stop or start fluid flow. This disc can also regulate the amount, pressure and temperature of fluid passing through in any position prescribed. A throttling valve will have a higher pressure at one end and a lower pressure at the other end. So this closes the valve depending on the degree of pressure. Next, let us explain a little about throttling process. So, what happens in throttling process? A throttling is a process where a high pressure fluid is converted into low pressure by using a throttle valve. In a throttle process, the enthalpy remains constant and the work done is zero. The purpose of a throttling device is to reduce the pressure of a flowing fluid. A variety of devices can be used as throttling devices. A significant reduction in pressure can be achieved by introducing a restriction into a line through which a gas or liquid flows. This is commonly done by means of an adjustable valve, a force plug or a capillary tube. They are called throttling devices. A capillary tube is tube with a very small diameter. Throttling devices are usually very small. As a result, there isn't much area for heat transfer. The operation of throttling valve is converting a high pressure fluid into low pressure, and then it's regulating the supply of a fluid as steam to an engine. Next, controlling the volume of vaporized fuel delivered into cylinders of an internal combustion engine, and restrict the flow to drastically drop the pressure, which will cause a large temperature drop within the fluid. We continue with application of throttling process. The throttling process is commonly used for the following purposes. First, for determining the condition of steam, dryness fraction. Second, for controlling the speed of the turbine. Third, use in refrigeration plants. Fourth, air conditioning system. 5. Hydraulics. 6. High temperature application. 7. Pharmaceutical applications. 8. Chemical application. 9. Food processing applications. 10. Fuel oil system. What happens to the fluid flowing through the throttling valve? When the pipeline uses throttling valve, the fluid flow rate changes. When partially open or closing the valve, there is a restriction in the flow of fluid, thus the control of fluids. This, in turn, compacts the fluids in that partially open valve. Molecules of the fluid begin to rub to each other. This will create friction. This friction additionally slows down the fluid flow as it passes through the valve. The system needs the cooler gas to be at the required hotter condition. With the throttling valve in place, gas temperature increases. This is due to molecules rubbing each other as they try to get out of the valve through a limited opening.
In this video, we will show you how to conserve the mass and energy on throttling valve. The mass flow of the throttling valve will be constant, with the equation of mass in equal to mass out, or mass flow rate in equal to mass flow rate out. Throttling valves are usually small devices, and the flow through them may be assumed to be adiabatic, since there is neither sufficient time nor large enough area for any effective heat transfer to take place. Also, there is no work done and the change in potential energy, if any, is very small. Unlike turbines, they produce a pressure drop without involving any work. The pressure drop in the fluid is often accompanied by a large drop in temperature, and for that reason, throttling devices are commonly used in refrigeration and air conditioning applications. Taking all of this into consideration, the following energy balance equation for a throttling valve will result. So, in this slide, we will answering the question, which is, did the throttling valve have any impact on environment, economy, and human health? Actually, the throttling valve didn't give any impact on environment and human health. So this will be the answer for the concept of environment and human health. The answer is no. But the impact is on economy, because this throttling valve is currently and mostly used on certain products like turbine, automobile, air conditioning, and many more things. So it's kind of like help to build better performance on this kind of device or components. So that's all from us. Thank you for your support, and Assalamualaikum warahmatullahi wabarakatuh.